Today we're on page 3 of our Chapter 16 notes packet. We're looking at probability, section 16.3. Probability is the number of successes divided by the total number of possible outcomes. For example, if you take rolling a die, a single die, what's the probability of rolling a 6? All right. Well, how many 6s are there on the cube of a die? There's only one. And what are all your possible outcomes? There's a 1, 2, 3, 4, 5, or 6. So that would be 1 out of 6. Or we can express this as a decimal. All right. Usually probability is expressed as a fraction, but oftentimes it can also be expressed as a decimal or as a percent. 1 divided by 6 as a decimal would be 1.6 repeating. I think I said 1.6, excuse me, that'd be 0.16 repeating. Or as a percent, I take the decimal point, move it 2 places. Or approximately, I'm going to say approximately 17%. Probability is always greater than or equal to 0, but less than or equal to 1. All right, so you cannot have negative probability, nor can you have probability that is greater than 1. Theoretical probability of an event is the number of ways that an event can occur divided by the total number of possible outcomes, when each outcome is equally likely to occur. For example, what is the probability of choosing a month that begins with the letter J from the months of the year? Okay, well, how many months do we have? We've got January, February, March, April, May, June, July, August, September, October, November, December. So we have 12 months. So that's our total possible outcomes is 12. And out of those 12, how many actually begin with the letter J? Well, there's January, June, and July. So that would be 3. The number of successes in this case would be 3 out of 12. Or we can reduce it to 1/4, but it's not necessary to reduce probability. Or we could write it as a decimal, 0.25, or as a percent. I prefer to leave it as a fraction. All right, but just keep in mind if you're ever looking at a multiple choice question, the answer might be in the form of a fraction, a decimal, or a percent. Next example, after arranging the letters tomato, what is the probability that the arrangement begins and ends with a T? Okay, so we're looking for the probability that it begins with a T and then ends with a T. So I use capital P for probability. Begins with a T, well, how many T's are there? There's 2 out of the total number of letters, which is 6. And ends, remember, whenever we're talking about in probability, when we see the word and, that means to multiply. And ends with a T times, well, a T has already been pulled out from those 6, so now there's only 1 T that remains from 5 letters that also remain. So we multiply 2 6 times 1/5, which is equal to 2/30. Or we can reduce this to 1/15. Next example, you pick 3 different numbers from the numbers 1 through 50 to win a lottery. What's the probability of choosing all 3 numbers? Okay, so there are 3 winning numbers. All right, so let's say so the probability of getting the winning number followed by the next winning number followed by the next winning number. Well, there are 3 winning numbers. Okay, so there are three winning numbers. So first draw, you pick one of the three, 3 out of 50. And then the second one, you pick the next one, but there's two winning numbers that remain out of 49. And then the third one, there's one left out of 48. Okay, and if I multiply that, that's 6 over 50 times 49 times 48 is 1,760, which reduces to, 117,600, which reduces to 1 over 19,600. Your chances are very small, very slim. The other way to think of this is you need you're choosing 3 of the 3 winning numbers. So let me do an OR over this way. From the 3 winning numbers, you choose 3 from the total 50, you choose 3. And that would result in the same fraction. Next, we have empirical or experimental probability. That's when it's arrived by observing data or the result of an experiment. It's a best estimate of the theoretical probability based on a large number of trials. For example, if Miles takes 50 shots from the free throw line in basketball and makes 28 baskets, then his empirical probability of making a basket is 28 out of 50. Next, we have geometric probability, and this is best shown with examples. You divide the area of the two regions. You have an inner or smaller region by the outer or larger region to get the probability. If you throw a dart randomly at the target shown below, what is the probability you will hit the shaded region? Okay, so in the first one here, for A, we've got this shaded triangle, and our dartboard in this case is a square. So the area of our inner or smaller region, the area of the triangle, would be divided by the area of the larger or outer region, the area of the square. Recall, what's the area of a triangle? 1/2 base times height. And area of a square is simply base times height, or side times side. So we have 1/2, 3 times 2, divided by 6 times 6. So this is 3 over 36. Or if I reduce this, 1/12. Or if we put it into a calculator, 1 divided by 12 is 0.083 repeating. Our next dartboard, we have a circle shaded in the center, and then our outer area is that of a rectangle. So we would take the area of the circle and divide it by the area of the rectangle. Area of a circle is pi r squared. Area of a rectangle, base times height, or length times width. What's our radius here? It's 2. 2 squared is 4, so I'll write this as 4 pi over 5 times 8 is 40. So we have 4 pi over 40, which we can reduce, dividing by 4, to pi over 10. Or, if we go to the calculator, key in pi divided by 10 All right, I have this decimal that's non-terminating, so I'll approximate it to be 0.314. So that's approximately 0.314, or if I write this as a percent, 31.4%. And lastly, we have the probability of more than one event. If two events occur at the same time, we say the probability of A and B, or the probability of, parentheses, A and B, and we multiply the probabilities. And we've already seen this before. For example, if you roll a die and flip a coin, the probability of getting a 3 on the die and heads on the coin, we would take the probability of getting a 3 on the die, which is 1 out of 6, and times probability of getting a head on the coin. Probability of getting a head on the coin is 1 out of 2. And we multiply and get the 1/12. On the other hand, if two events are exclusive of each other, we say that the probability of A or B, whenever you see or in probability, we add the probabilities. For example, if you roll a die and flip a coin, the probability of getting a 3 on the die or a heads on the coin is, whenever you see or, you are adding. Probability of getting a 3 on the die is 1 out of 6. Probability of getting a head on a coin is 1 out of 2, so we add 1/6 plus 1/2 is, make sure you get a common denominator here. I know how you guys love fractions. All right, 1/2 is equivalent to 3/6, and we add, we get 4/6, which reduces to 2/3. For example, if you pick a card from a deck of cards, what is the probability you'll choose an ace or a king? All right, so I think I'll say probability of ace or king. What's the probability of getting an ace? Well, there's 4 aces out of the 52 cards, or a king. And there's 4 kings out of the 52 cards. Adding this, we have 8 over 52. If you pick 2 cards from a deck, what is the probability you'll choose an ace and a king? All right, in that order. So we have the probability of an ace and a king. The probability of choosing an ace is 4 out of 52 times probability of getting a king. Well, there's still 4 kings in the deck, but now there are 51 cards left. Multiplying this, we get 16 over 2,652. And this concludes our lesson. Thank you very much.